Hello and good day. In geometry, we're covering CO2 using algebra to find segment length and determine if two segments are congruent. This may be a new term to you, congruent. No. What does congruent mean then? Sebastian?
Same.
Okay. Yes. A little bit more. Nick?
Equal.
No, that's the thing with congruency. Is congruency does not actually mean equal to. Okay, that's why we have a whole different symbol for equal to. And if you'll notice, the congruency symbol is like the equal sign, but it's got the little squiggly over it there. Okay, so Sebastian said the same. Hold on, yeah. Yes, that's exactly what I was going to do. I only put same size and shape, but perfect. Yes. Nick, you said wait? Okay. So congruency means same size and shape. Okay? Same size and shape. There is a difference between congruency and equality. Okay? Congruency, same size, same shape. You notice that these tables, you could say these tables are congruent. They're the same size, they're the same shape. However, they might not be equal. Maybe you met your best friend sitting at the table you are at. So that table might have more meaning to you than another one, right? So congruency, they're the same, but when we're talking about value, we use the equal sign. Equality has to do with value. Congruency has to do with just size, shape. All right? So when we talk about this, and this is going to come up when we do proofs in a little while, but just the difference between these two symbols, boys. Okay? Also, that tick mark there, that is the congruency symbol. If we want to say that these two segments are the same size, same shape, we would say that they are congruent. But as soon as we assign them a value, say they're both 7, now we can say that AB is equal to CD because we've introduced a value to them. Without that 7 there, they're just things. We don't know what the value is. So we say they're congruent. Okay? The segment addition postulate. Do we want to take a guess as to what that means, or should we just... Nick?
Segment plus segment equals.
You're actually very, very close. Yeah. The segment addition postulate basically says that the parts of a segment sum to the whole segment. The parts of a segment sum to the whole segment. You're going to see things like postulate and theorem come up a lot here frequently. Remember I said with a math packet that in defending the answer, you have to explain the reasoning why? That if you're a lawyer and you say, my client is innocent because he looks innocent, and that's your only rationale, you're not going to win a lot of cases, right? So you have to defend it, okay? You have to explain it. You have to logically work your way through it. So the word postulate, when you see it, kind of just earmark that for later on. When we get to proofs, which is a logical explanation of why something is the way it is, you use these postulates and later theorems pretty often. So it seems pretty obvious the parts of a segment sum to be the whole segment, but rather than saying that, it's just easier to say the segment addition postulate. Or if you're really lazy, the SAP, S-A-P, okay? The SAP, right? But that's what it means. And so we can use this mathematical relationship to help us answer questions like the ones that I have here. Okay? It says find the segment length, GH. Notice there is no segment line above GH, right? In CO1, we said GH, you could represent that with that notation over it. The reason why there isn't one here is because we're not naming it a segment, we're looking for its value. Okay? There's a big difference between just naming something and the value of something in geometry. So without that segment notation above it, that means I'm looking for the value of it. And what is the value of GH? Nick? How do you know?
I subtracted 36 minus what was between F and G, which was 21.
Say it again?
I took the 36 and subtracted it by what was between F and G, which was 21, and I got 50.
Okay, so if we, based on the segment addition postulate, we know that FG plus GH equals 36. And we know that because FG and GH are parts of the whole segment. Oh, I shouldn't have written 36. FH, right? Because FG and GH are parts of the whole segment FH. If we know that FG is 21 and GH is what we're trying to find, FH is 36, well, now it becomes a simple algebra equation, right? 21 plus what number equals 36, and that's where we get GH is 15. Sebastian?
On my paper it says 35.
No, it's 36.
It should be a 6.
That's 5.
That'll be the first time in history that a copy and paste would result in different values. Okay? Okay. How about the measure of WX? Same kind of thing here. Based on the SAP, we know that VW plus WX equals VX. The parts of that segment will equal the whole thing. Once we plug in the information that we know, the relationships, right? 37 plus WX, what we're trying to find, equals 144. We've identified the relationship, and now we can use our math skills to solve it. McKenna? 107. Because 37 plus 107 equals 144. Okay? It seems pretty obvious, seems kind of elementary even, but this is essentially what geometry is. It's looking for those relationships and being able to express them, sometimes in equations, sometimes in words, but this is the gist of it. Yeah? General rule of thumb, anything that I put up here, it's because I want you to have it on your page also. Okay? Ultimately, it is yours, so you can make that choice, but except for the homework. Like when I specifically tell you homework needs to be this way, then it has to be that way. But your notes are kind of your own notes here. But yeah. All right, the next section. Try a few slightly more complex examples. You may find it helpful to draw a picture. Okay, so this says point B is between points A and C. I don't know how far point B is between A and C. Is it closer to A, closer to C, right in the middle? I don't really know. But if we're just drawing a sketch, it doesn't really matter. So here's A, here's C, and point B is somewhere between them. Okay, that's the relationship that first statement says here. Point B is between points A and C. Now we're given some more information about AB, BC, and AC. AB is 2x plus 7. BC is 7x minus 8. And AC is 80. Here's a notation thing. How do I know, the way, based on how I wrote this, that 80 isn't referring to just AB, but that 80 is referring to the whole thing, AC. This is something that when you get to the textbook and draw it out can kind of throw people off a little bit. But how do I know, the way that I wrote it, that 80 isn't for AB? Yeah?
Because it says AC and not ABC.
But let's say you didn't have this here. Let's say, as I cover it up with my hand, you can still see it. Let's say the words weren't there, just the diagram. How would you know that 80 refers to AC? Yeah?
You wrote it below the line.
I wrote it below the line, and there's another something about it. Nick?
There's nothing else under the line.
Nothing else on the line? All clues? Yeah?
It's in like the middle.
It's in the middle. Okay? That 2x plus 7 is in the middle of A and B. That's how you know it's for A, B. 80 is in the middle between A and C. That's how you would know. The other way that you might see it is with, oh, sure, now I got to fix that. You might see something like this, showing you that's the whole thing there. Either one works there. Yeah, Sebastian.
Never mind.
Okay.
I'll just say the answer.
Oh, well, we'll get there shortly. So now that we have this picture, now we're kind of back up to what we did here, right? Based on the segment addition postulate, we know that AB plus BC equals AC, right? The two parts of that segment, AB plus BC equals AC. We know that AB is 2x plus 7 plus BC, which is 7x minus 8, equals AC, which is 80. So like I said, slightly more complex than what we did up above, but really just the same thing. We're putting the pieces in place here, identifying what the relationship is, and now again, we have an algebra equation to solve. Okay? I'll kind of do my work over here. Give myself a little more space. 2x plus 7 plus 7x minus 8 equals 80. How does that equation simplify? The left side of that equation, how does that simplify? Yeah.
Subtract even 7.
Sorry?
Subtract even 7.
We could. I don't want to move anything yet, though. You're right. That's not a wrong process to start with. But I want to just combine like terms and get it down to a two-step equation first. So how does the equation simplify? Yeah. Yes. Kylie? Yeah.
2x, you would add 2x plus 7x to get 9x.
Good. Those like terms, right? 2x's and 7x's is a total of 9x's. How about our constants? Positive 7, negative 8. McKenna?
Negative 1.
7 minus 8 equals negative 1. And so we have the two-step equation, 9x minus 1 equals 80. Now it's add 1, divide by 9, right? And we get a value of x equals 9. So the algebra does come up a little bit, but not too bad yet. Okay, is that the answer? No, it's not. No, it's not. Algebra, right? It's always x equals this, then we're done. The question was, or the task was, find A, B, and B, C. Solving for x is part of that, but now that we know that x is 9, what is AB? Yeah.
Well, it's 2 x plus 7, which if you put in the 9, it's 2 times 9 plus 7, which gives you 25.
Right. If AB is 2x plus 7 and x equals 9, then 2 times 9 plus 7 equals 25. Did I put my B in the right spot here to be drawn to scale? Oh, it should actually be closer to A, but that's okay. It was just a sketch. Just a sketch. How about BC? 7x minus 8. What is BC? Yes.
55.
What was it?
55.
No?
Yeah.
Did you say 50?
55. 55.
Like 55. 55. Yes. Okay. 55. Sorry. Got to clean up my ears. Must not have heard you. Okay. All right. Questions, comments, concerns, complaints, comments, congratulations, or criticisms on that? All right. I'm going to have you do the second one on your own here as homework, and then I'd like to start to set up the last one, because if you look at it, it's a brain buster, so you know you're in for a ride here. It says draw a segment AF that includes points B, C, D, and E in between and in that order. Then it gives you a whole bunch of information, and then you need to find a whole bunch of things. So I'm going to set this up so you can kind of get a starting point. And then you have time to work on it today, or if you want to take off a little bit early, that's fine as well. But you've got the second one of these to do for homework, and then whatever we don't get through in the brain buster, and that is of course due Thursday. Okay. So let's scroll down a little bit so we have ample room to write here. All right. It says draw a segment AF that includes points B, C, D, and E in between and in that order. So I'm just going to draw. There we go. That should be big enough. A is over there. F is over there. Now, before I place the rest of my points, I'm going to read through the given information just in case there's something I might want to consider. It says AC is congruent to CE. Okay. It says AC, segment AC is congruent to segment CE. So wherever I put point E, which I know is going to be, somewhere to the left of point F there, where does point C go? In the same spot as point E?
No, same spot.
Halfway between A and E, right? Because if the distance from A to C is the same as the distance from C to E, that means that C is going to go in the middle. Okay? If I put my C too close to A without reading that first, then my whole thing's going to be off. It is just a sketch, but we do want to make it, use the information we have to make it as accurate as possible. So AC is congruent to CE. Point B, I don't know if it's closer to A or C. Last time I put it closer to C, so this time I'll throw it a little bit closer to B or closer to A, just to be fair. And then point D, I don't know, we'll put that closer to E, see if we're right. We for sure have A, C, and E relationship the right spot. All right. We know that A to E is 50. What other information can I glean from that? That if AE is 50, Elise.
The distance to AC from A to C is 25.
And? If AE is 50 and AC and CE are congruent, that's why I put C in the middle, right? It means that one can't be 20 and the other 30, or 40 and 10. It's got to be 25, 25, because they're congruent. All right. Did I have to find AC? Yes, I did. Got that one done. Did I have to find CE? Yes, I did. Got that one done. We're cruising. All right. CF is 35. CF is 35. What information can I glean from that? We know that CE is 25. You're being told that CF is 35. Get your hand up and put it, yeah?
Would it be EF is 10?
EF has to be 10, right? Because if the whole distance from C to F is 35, and we already knew that C to E was 25, that leaves 10 for EF. Follow me? Okay?
Yeah.
So that's the type of remember I said geometry is like a puzzle? That's how the puzzling works. Okay? Some things you have to find before you can find other things, but you're looking at the relationships and how they all fit together here. How they all fit together. So we're going to stop there with this one. See what you can do with the rest of it, and we'll chat again on Thursday.
What time is it?
For homework is the rest of CO2, right? The one, this one here that we didn't do, and then this one here that we didn't finish. That's your homework. CO1 you should be finished with because we made it through the entire page. Yeah. All right. That is how you math.
Go,